This is Algebra 2 with trig. This is Unit 5A.1. We're going to evaluate the nth roots and we're going to use rational exponents. Before we get into this page, we're going to come back to our table of powers. So what this table of powers is talking about is simply taking the 1 and squaring it, taking the 1 and cubing it, taking the 1 to the 4th power, 5th power, and 6th power. The same thing, you square the 2, you cube the 2, the 4th, the 5th, and 6th power. And you do that for each of these numbers. The gray boxes mean you don't have to quite go that far, because that gets to be really large numbers. But for the number 6, we will square it, we will cube it, we'll do that for each of the remaining values. So, go ahead, try to fill out your powers table, then I'll come back and I'll show you the values. Here's our power table. When we're taking 1 and timesing it to itself multiple times, or 2 times itself multiple times, and so forth. As we work through this, we start to see some patterns of where different values are repeated. But we can refer back to this list and it'll help us in some calculations that we're doing. So now we're going to go back to our other notes. This is our Unit 5A.1. We're thinking about perfect squares. So you look back at that table and you notice that what numbers are being squared. 1 gets squared. 4 is a perfect square. 9 is a perfect square. It's an infinite, an infinite number of perfect squares. Perfect cubes. 1 times 1 times 1 is still 1. 2 times 2 times 2 is 8. 27. 64. And that pattern can go on. We can see that on our powers table. So now what we're looking at is the nth root of a. For an integer n greater than 1, the n value, the exponent, is greater than 1. So b to the nth power is supposed to equal a. b is considered an nth root of a. Thinking back to what we know about, we know that 3 squared, that equals 9. So the cubed root of 9 equals 3, where b is the nth root of a. So the b value is the nth root, the square root of a. So that's what that all means. And when we're writing this out, the a value is what goes inside of a radical, and the exponent is our value that is writing as what we call an index. That's the number that goes on the upper corner of a radical. So in a square root, we don't typically write a number here. If we want a cube root of a number, we have to write it to be a 3. If you want the cubed root, or let's say the 4th root of 16, what times what times what times what makes 16? That's going to be the number 2. You have to write that index number. That is telling you how many of the same value inside the radical you're looking for. 3 of a kind gives you 2. In this example, 4 of a kind made 16. So the 4th root, 4 of a kind, happens to be 2. In this case, we're looking for a pair of the same numbers to make 9. A pair because it's a square root. So if we are solving an equation, it has to be a solving question. If the exponent is an even integer and the a value is negative, we're going to have no real roots. So b to an even degree equaling a negative number, that's going to be the square root of -4, and we know that that gives us an imaginary value. When we're talking about solving, we're going to have plus or minus when you're taking the square root of both sides of an equal sign. When we have b squared that equals 0, when you take the square root of both sides of the equal sign, you could call it plus or minus 0, but it's still only one answer. So notice here, when I did the square root, I did not write a 2, like I wrote a 2 here. Here I was showing you where that 2 goes. It's called the index of a radical. Usually when we do square roots, we don't write it, the number 2 in the corner. Here we're working again with an even index, so we could easily be writing or working with a number that's larger than 2. Let's not pick that one. Let's pick that one. Okay. So what we would do would be the 4th root of b to the 4th and the 4th root of 81. That would be b equals plus or minus 3. So again, you get 2 real roots. That's where the plus or minus comes in. When it's even, you could have 2. Here, you really get none. You get to 2 imaginary is what I was showing you there. And 0, you don't get a plus or minus because plus or minus 0 is the same location. Now, if n is an odd degree, like b to the 3rd power equals a negative number, we can take the cubed root of a negative number, and that just works out to be -2. You only get one answer when you take the cubed root of -8. And that answer would be -2. The cubed root, or any odd root for that matter, you're only going to get one answer if you're working with a to be 0. So when we take the cubed root, you got to write the 3 in the corner. B is going to be 0. You only get one answer. And even if a is a positive number, when you take the cubed root, you're still only going to get one answer. There's only one way b can cube itself to become 27, and that's 3 times 3 times 3. -3 times -3 times -3 would make a -27. All right, so when you have even integers for your index, you can have a plus or minus answer. But when you have an odd, you're only going to have a single answer. But that is when we're solving equations. Here, we're looking at our fractional exponents. And you already know that when you take a value times a fraction, you multiply just the top of the fraction. So that's how you get m over n. Well, in this case, we're actually just pulling that m, like factoring the m out of it. Now you've learned that the index is the same thing as that denominator. So if you have a fractional exponent, you can actually write that with a radical in its place. With a negative exponent, we put the fraction into the denominator. We can still separate it into two separate parts, which would give us a radical in the denominator, and it's raised to the m power. Using those properties, how are we going to apply this with the number negative 125 raised to the power of negative 2/3? What does the negative exponent do? Puts it into the denominator. Now, if it's moved to the denominator, we don't have the negative symbol on the exponent anymore. Then we talked about separating it, getting you to focus on just the 1/3 part. And then the 2 would go on the outside. So you should know what the 1/3 root or 1/3 exponent is. That's the same thing as the cubed root of your 125, and that is being squared. What number times what number times what number makes 125? If you flip back to your power table, you'll see that under the cube, 125, 5 times 5 times 5 makes 125. So the cubed root of 125 is 5. So the cubed root of negative 125 is negative 5. We still are squaring, and that's going to come out to be 1 over 25. So recognize the steps that it took to get there. We did not use a calculator. We showed our progression. So we got our 1 over 25 is the same thing as where we started. So that's the majority of the notes. Most of this rest is just practicing that same type of stuff. So here we have 64 to the negative 1/6. What I notice first is that this is a negative 1/6. You need to be observant. So I have a negative 1/6. That means I'm going to place the 64 into the denominator with a positive 1/6. And that means I'm supposed to take the 6th root of 64. I can use my power table . Here somewhere, I can use my power table to try to find the 6th root of 64. 6th root of 64, and that's going to be the number 2. So that's how you use this power table. You don't have to always have a calculator. So 64 to the negative 1/6 power is the same thing as 1 over 2. Nine to the 1/2 power cubed. Now what would be good is if you can start recognizing what the 1/2 might mean. The 1/2 would mean the square root. So what is the square root of 9? The square root of 9 would be 3. Remember, don't get that confused with the square of 9, but the square root is the idea of putting it inside of a radical. The square root, 3 times 3 makes 9. And this is 3 to the 3rd power, which is 27. We have 16. We notice we have a negative exponent. So we're being observant to that, and we're writing our 16 with a negative exponent, which means we're going to write this as the 4th root of 16. And we know that 2 times 2 makes 4, times 2 is 8. The 4th 2 is 16. So the 4th root of 16 is 2. You can notice that on your power table. And we can finish this up by saying 36 to the 1/2 power, because I'm going to pull the 3 off of the fraction and put it on the outside. You know that a 1/2 means a square root, and we're cubing that, so we get 2/16. You can look on your power table that 6 to the 3rd power is 2/16. Now it's your turn. You go ahead and try these 3 problems. Pause the video, give it a workout, see how it goes. So the negative exponent puts it into the denominator. Then we can break that fraction up. We know 1/3. 1/3 refers to the cubed root. And when we're dealing with the cubed root, we want to be sure to work with the column that has n cubed. So where is our 8? So that's going to be 2. The cubed root of 8 is 2. So the cubed root of 8 is 2, so that's 2 to the 4th power, which is going to be 1 over 16. Now we're going to do 1/8. We don't have a negative exponent, so we're going to skip that step. Now we're going to break the fraction apart. What number times what number times what number times what number times what number? 8 times in a row is going to make 1. That's, of course, 1. And then 1 times 1 times 1 times 1 is 1. 1 to any power is always 1. No negative exponent, so we're going to break this apart using the fraction, the 1/3, using the 2 on the outside. I know that the cubed root, this is the same thing as the cubed root of 27. If you need to convert it for now, that's fine. The cubed root of 27 is 3. We're squaring that, which gives us 9. We've got some calculator questions we can do. Notice we did all those without a calculator. Sometimes we used our power table, but we weren't relying on a calculator. Here we know the 1/3 implies that we are doing the cubed root. So to get a cube root on your graphing calculator, you hit the math key, and number 4 takes you to the cubed root, and you can write 10. So that comes out to be approximately 2.15, and that's rounded to the 100th. Here, notice we have a negative exponent, so we're going to write the 21 in the denominator with a positive exponent. Well, that means 1 over the 4th root of 21. So we can say 1 divided by, you could say 21 to the 1/4. That's one way you could do it. Or you could say 1 divided by, we write our 4 as our index number, go back to math, down to the 5th spot. Look at the x, that's taking the value you put in front, and notice it makes it as your exponent. It's not an exponent, I'm sorry, it's called the index. And we put 21 in there, and you'll see you'll get the exact same value. So either method you like to use. So this is approximately 0.47. So the 6th root of 13, we're going to type the 6 first. You're going to go to math, down to the number 5, and that's going to put the 6 as your index. What times what? Times what? Times what? Times what? Times what? Makes 13. And that's going to be 1.53 apparently. 1.53. So if you take that number and raise it to the 6th power, you're going to go right back to 13. Then our last one here, notice if you want to type it in exactly the way it is, you could write the 4, go to math, down to the number 5, so you put it in as an index. Put your 80. You got a tab or arrow out of the radical. Then you could raise that to the power of negative 1 divided by 2. If you're using a calculator, you can just do the calculator work. That's approximately 0.58. Now we're going to be solving equations. This is where we have to take into account the positive and negative. To solve an equation, x to the nth power equals a, we're going to take the nth root of both sides, or we're going to raise to the power of 1 over n. So in this case here, we're going to solve it just like we normally would. Got to first divide by 2. This becomes 729. So the sixth root of x to the sixth, we would do that to both sides. So x is going to be plus or minus. We can look back at our power table, and we're looking for 729 as a sixth root. So we know that that's going to be 3. And we did that without using our calculator. So plus or minus 3 in that spot would give us this answer of 1458. Here we have x plus 8 to the fourth power. We could raise that to the 1/4. That's this idea here that we're raising it to the 1 over n. So that's going to be 2 to the 1/4. Those would reduce each other out. That'd be 4 over 4, which is a value of 1. So that's x plus 8 to the first power. Here, using our calculator, 2 to the 1/4 power, you could write it as a radical, you could write it as a rational exponent. We get the answer of plus or minus 1.19. That means we have x plus 8 equals 1.19, or we have x plus 8 equals negative 1.19. We're going to subtract the 8 from that and get x equals negative 6.81. Or we could take a look at this, and we could subtract 8, and we'll get x to equal negative 9.19. So you get two different numbers that could be plugged into this to help us calculate that. So here we're working with an odd degree. So when we have an odd degree, we're not going to have plus or minus. So we're going to add 9. That's going to give us 40. So we're going to do the cubed root to get rid of the exponent. We have to do that to both sides. Because it's an odd degree, we're only going to have a single value that equals it. So if we go to the math key, we can go down to cubed roots and type in 40, and that's easily seen to be 3.42. Approximately, it's good to show that symbol, 3.42. Okay, we're going to take a look back here at letter D. Something may have gone wrong with letter D. So this is for the fourth root of 80 to the negative 2 power should be 0.11. Not quite sure what happened there. All right, I got two little story problems. The population of a certain animal species after T months can be modeled with this equation where C is the initial population. Find the population after 19 months if the initial population was 75. So the initial population, okay, the population of P after T months, where C is the initial amount. So we're told the initial amount was 75. And it's growing at a rate of 1.21. T is our time, and that's after 19 months. And we want to figure out what P is. So we could go to our calculator. Those are not numbers you would want to do by hand. These are not numbers that are on our power table. And we're going to raise that to the power of 19 divided by 3. That's going to be 250 of these animals. All right, so you could call it 0.8, and that would be fine. You could round it up to 251, but usually when we're talking about an item, we don't have 251 items, so we have less than 251 items. We have 250 of those items. Okay, so we'll come over here to our last one. The volume of a beach ball can be modeled by this equation. We did that in geometry, where r is the radius. Estimate the radius of the ball if the volume is 382 4/3 pi r cubed. So we want to get the r by itself. So that means we're going to multiply by 3. So 3 times 382. So 3 times 382. That gives us 1146. 1,146. Now we can divide by 4 pi. So we divide this. You should use parentheses. 4 pi, the pi key is at the caret key. That gives us 91. And I'm going to put 19. It won't really matter because I'm going to use the exact value in my calculator anyway. Now I'm going to do the cubed root of 9119. I'm going to do the cubed root. You go to math, down to the cube root. Now, you don't want to type in because that would be very much a rounded value. You want to use the answer button, which is found here just above the negative. And that gives us 4.5. That would be the radius of a beach ball with a volume of 282.